Okay, 2.6 related rates. It's the last section in the book. Don't try to skip steps. That's all. Don't try to skip steps because you'll just confuse yourself and you'll be running in circles. Okay, so important use of the chain rule is to find the rates of change of two or more related values that change with respect to time. You don't need to write this all down. So what this is you see this cone. You see how it's full in the first picture?
Yeah.
And then it's losing, and then it's losing more. So what things are changing? Time is changing. What else is changing?
The amount of fullness.
Okay, so the volume.
Yeah, that.
The height of the water.
The height of the water is the radius of the water changing. So there's a lot of things changing. So in this equation, because volume of a cone is pi over 3 r squared h. So the volume is changing over time, but the radius is also changing and the height of the water. So you have things changing altogether. It's just not one thing changing. So, and this, think of other things. Can you think of something else that changes? There's more than one thing changing at a time?
The puddle.
I don't know, like a joint.
The puddle. Okay. The puddle, the radius is getting larger, the puddle, What about a swimming pool? When you drain a swimming pool?
When you drink a swimming pool, I don't know. That
Yeah.
definitely
When
would
you
change.
drain a swimming pool. What about if you blow up a balloon?
I suppose it would change.
Is the volume of the air changing with the radius of the balloon?
I suppose.
Okay. So anything that multi-variables are in. An example of this is when water is drained out of a conal tank. That is so weird. So what we do is we take the derivative not with respect to x, but with respect to
Velocity.
time.
To that.
Oh.
Oh.
Because these variables are changing according to time. So when I did that, I would have dv dt
It's good.
equals 2/3 pi r dr dt dh. Oh, nope, I wouldn't. I was trying to pull a Kale.
Oh,
I was trying to pull a Kale,
what did I do?
not do my product rule. So we would have RH dr dt, right?
Wait, which one of these equations are we supposed to write down?
We're differentiating.
We're differentiating the one that's...
We're differentiating. Let me start over since I lost you. We're differentiating both sides of this.
What is that equation?
That's the volume of a cone.
Okay.
Okay, so we would have dv dt. And I'm going to spit out the pi over 3. You guys good with that?
You're just going to spit it out.
Spit it out. Okay, so then I would have 2RH dr dt
Yeah.
plus r squared dh dt. So in order to solve for dv dt, what would I have to have? What would you have to know?
Something.
Well, what are all the variables I'd have to know to be able to give somebody an amount for how the volume was changing with time? I'd need to know what? Radius, height.
and volume.
I would have to know r prime, yes,
Yeah.
and h prime. So I would have to know all of those things in order to give you an answer for dv dt, wouldn't I?
Yeah, but we don't.
I don't in this one. So when we are doing these problems, we are going to have to write down what our equation is going to be and what our given things are going to be and what we need to find. So we'll have a 3-step process of things we write down. Okay, suppose it's really small, isn't it?
No.
No? Okay. Suppose x and y are both differentiable of t and are related by the equation y equals x squared plus 3. So our equation is y equals x squared plus 3. We're going to have a given, and we're going to have a find. So it says find dy dt when x is 1, given that dx dt equals 2.
What does this say?
Okay, when x is 1. You can, what?
I could not figure out what when was.
Oh.
I kept seeing the W as like a one.
Oh, I'm sorry.
I get it.
You get it now? Okay, so you're going to classify your information in terms of equation, given, and find. So we now have to differentiate with respect to t. So d dt, d dt. So we get what? Y prime. Can I put y prime, or do you want me to? Actually, I'm going to put dy dt for a little bit. So just we can see it really definite. And then what do we have? 2x dx dt. Okay, I did that fast. Everyone good with it though?
Just let's sit here for a second so I can write down and realize what you did.
Yeah, let's also say everything.
All right.
Natalie, are you good?
Give me 1 second.
That's fine. I'm just asking.
Okay, you can keep going.
Okay. So I need dy dt, and I'm good because I'm already solved for dy dt. If it wasn't solved for it, you need to solve it for what you need. Okay? So, do I have an x?
Yeah, 1.
A 1. Do I have a dx dt? A 2. So it's 2 times 2 times 1. So dy dt equals
5.
4. Now, you'll need most of your problems are application problems, so they will have units. So you need to make sure you discuss your units. I don't think 5 and 7, I don't think have units, or maybe just 5. Just 5 doesn't have units, but everything else does. Okay, so a pebble is dropped into a calm pond, causing ripples to form concentric circles. That means circles inside of circles, right?
Yeah, it does.
Okay, they give you a picture. Nice, pretty, serene. The radius of the outer ripple is increasing at a constant rate of 1 foot per second. When the radius is 4 feet, at what rate is the total area of the disturbed water changing? Now, the solution's there, and I should have covered up the solution because we're not going to be given that. Like in your problems, none of this is going to exist. You have to figure all that out.
Even the area equals times 20.
Yep. Everything that's not given. Okay. That really didn't. There.
Good thing I remember all of
Okay. So the things I told you had to have are what?
An equation.
Equation.
A given and a find.
Okay. An equation, a given, a find. So I have an equation. Given. And a find. So we're talking about what shape?
We're talking about the
Circle. And what of a circle?
the circumference, the area.
I never heard the word circumference in there.
Area.
Area. So what is the area of a circle?
Area equals pi r squared.
Okay, so area equals pi r squared.
What about when like we don't know the equation for like pyramids?
Then you gotta go look it up. Okay. So then is, let's see. What do we know?
I don't know.
Radius is 4 feet. And that.
Okay. Well, it says the radius of the outer ripple is increasing at a constant rate of 1 foot per second. So wouldn't that be dr dt?
I guess I don't know why,
Yeah.
but
Because
it is.
dr dt means the change of the radius over time. See that? Because we're talking derivative is the rate of change, right? An instantaneous rate of change. So the derivative of r with respect to t is telling me that that's the rate of change of the radius is 1 foot per second.
Yeah. I need to find
Okay, so when the radius is 4, what is the rate of total area? So I need d what?
dA dt.
I need dA dt
Dotted
when
r equals 4.
when r equals 4. Now, did everyone get how we got all that information?
From the equation.
From the, it talked about area, so that was my area equation, right?
Yep.
Okay, so anything changing is dA, because the derivative is instantaneous rate of change.
Yep.
So now I need to take the derivative with respect to what over here?
With respect to
T.
dot.
T, time.
Oh.
So what is it?
Would you set it equal to dA
Yes, because that's what you're looking for. So what do you have, Autumn?
dt? I have that so far. And then you'd want to find the derivative of pi r squared.
Right. Your derivative of everything. Isn't that just 2 pi r dr dt? The hardest part about this is the first step. The equation, the given, the find. It's the hardest part. And now what?
We have dr dt, and
And we have r.
we forgot to put that in our given.
Well, we have it in our
I guess we have it
find.
in our find.
Okay. It has to be somewhere. Some people put this when in the given. Doesn't really matter. So I have 2 pi times 4 feet times 1 foot per second. Now, the 1 doesn't make a difference, but what does make a difference?
Seconds.
The feet per second. So what do we have? 8 pi feet squared per second. And we're talking about the change in the what? Area, so we better get squared, right?
That is squared. I hate looking at that clock.
Question.
That's one another time.
Just look at it then.
Well, I did, but it took longer than it would have.
Why?
It wasn't like that.
Okay, am I good to go to the next one?
Yeah.
Okay, so this is just guidelines for solving related rate problems. Identify the given. You can make a sketch. Sometimes that helps. Write the equation. The variables whose rates of change either are given or are to be determined. The equation is based off of what they're asking for. If they're asking for area, it's area. If they're asking for volume, it's volume. You've got to think. Sometimes it doesn't really say straight out what they're asking you, but you guys know the difference between area and volume, right? What is the difference between area and volume?
Area is squared, volume is cubic.
Yeah, but area is one-dimensional.
Three-dimensional
Yeah.
concept. While
Yeah.
area is
Well, two-dimensional, I guess. Okay, use the chain rule, implicit differentiation, both sides. It's not always the chain rule, but use it. Sometimes you have to do the quotient rule. Sometimes you have to do the product rule.
What if I just don't?
And you're probably going to get a lot of them wrong. Okay, and then put everything back in and solve for what you need. Should you plug stuff back in, then solve for what you're looking for, or solve for what you're looking for, then plug stuff in?
They solve what you're looking for and then plug stuff in.
Right, because it's easier that way. Anybody writing this?
No.
Okay.
Yeah,
Are we
it might
supposed
be.
to? I thought we just talked
Well,
about
it's
it.
the steps, but like it's not really the steps.
Okay, so if I had the verbal statement, the velocity of a car traveling 1 hour is 50 miles per hour. So x is the distance traveled, yes? So dx dt would be 50 when time was what? 1. Water is being pumped into a swimming pool at a rate of 10 cubic meters per hour. Well, we are changing velocity, yes? I mean volume, not velocity.
Not velocity.
Volume. Volume. So we're looking, their equation would be a volume function, wouldn't it?
Yeah.
Okay. dv dt would be 10 cubic feet per hour. A gear is revolving at a rate of 25 revolutions per minute. 1 revolution is 2 pi radian, which you should already know, correct?
What?
So theta is the angle of revolution. So d theta dt is 25 times 2 pi radian per minute. So those are just some examples of things you might read and how to put them in. We good? Natalie, you good?
Yeah.
Okay. Air is being pumped into a spherical balloon. I love how they say spherical balloon. Like, what other shapes are there?
Like quality.
I guess those long ones. Yeah, I guess. Ooh, that would be fun. Okay. At a rate of 4.5 cubic feet per minute. Find the rate of change of the radius when the radius is 2 feet.
So we're finding dirt.
So we have equation. Oh, this thing is not keeping up with me.
It's too fast.
Given. I put my given too close. Your given and find don't need too much room. It's your equation that needs the most. Okay, so what do we know? What's our equation?
Our equation,
Doesn't tell me.
it doesn't tell you, so you just have to make it up.
But you're pumping air into a balloon.
A
So
spherical balloon.
so what kind of a...
We're increasing the volume of a sphere.
So what equation?
The volume of the
V.
equals
Do you guys know the
velocity
volume?
of the sphere.
Volume of a sphere is pi over 3 r squared h.
H.
Pretty sure.
Or is it cubed?
Oh, that is not even it.
not
I think I
Not even
wrote it
close,
down.
because that's the first one we did. Yeah?
True. But what was
Okay, it's 4/3.
That was a cone.
Yep.
Oh, it is.
Pi r cubed. I should have known that. I'm writing it going, this is wrong, this is
Well,
wrong.
you really bombed that one.
She had some of the things.
Yeah, no, not even. It's a circle. It should have pi. Okay, so given what? What do I know?
We're given that, that dirt equals 4.5 feet cubed per minute.
So we know d of e, dv of dt, can't talk, right? Equals 4.5. I have a feeling I want fractions. So what is that, 9.5 feet per second? Minute. Okay.
And we're finding this is where we're finding the dirt at when it equals
Autumn, yell at me louder. What? Now we have to find what?
dr dt.
dr dt.
Dirt at
Okay. When what?
when r equals 2 feet. All right.
So now what?
Now we find it.
Now we find it. We take d dt. Now again, what we just did was the hardest part, I think.
Well, this one might be a little different because there's a bunch of fractions.
But you only have one variable, so you don't have to do the product or anything.
Yeah.
I get 4 pi r squared dr dt.
Where's the 3 now? And why is it squared?
Yes, that's
Because I took the derivative.
Natalie's in a new world.
Okay. Let's just forget what we did the first week.
I do, that's my
Natalie,
issue.
look.
What?
3 comes here. This becomes a 2.
Yeah, that, and then be 12. Yeah, I get it now. It'd be equal to dr dt and then the dv dt would be in the equation. Or am I mixing that?
Say that again.
It would be equal to dr dt, right? Because that's the find.
Well, that's what we need to find, and it's not there. So we need to get it there.
And
Okay, so we need to solve it for dr dt. You are correct. Because right now it's set up to find dv dt. That's why I brought up, should we plug in or solve first? So if I want to solve for dr dt, I would divide by all of this stuff over here, right?
yeah,
So dr dt would equal dv dt
which is 9
divided by 4 pi r squared. So dr dt equals 9 feet cubed over 2 minutes times 1 over 4 pi, and what's r? 2, so squared would be 4.
Is this what we're supposed to be doing, or is
Yeah.
this another way?
No. So I think we get 9 over, what, 32?
Yeah.
Oh, this has a feet, right?
Yeah.
And then,
So it just becomes squared?
it can't be squared.
Well, but we're finding radius.
Yeah, but you can't have a square radius.
Okay.
Why not?
Where is our other foot?
Would it
Wouldn't
be-
this have a foot on it too? Oh, no. It would be foot squared because we squared the, yep. This would be squared because we squared the R.
I think I'll just figure out what the was after
No. So it'd be 9 over 32 feet per second.
Per minute?
Minute, not second. I always want minute. I mean second.
Your pi,
Yeah.
Did I forget my pi?
32 pi.
we don't have a full-blown pi day. with-
Well, I have the 2 because I have 16 times 2 is 32. I just forgot my pi. Which is approximately, the book says 0.09.
I don't care.
I don't either.
Maybe you should.
Would it be? I don't think that would be about 0.09.
You don't think so?
27 over 32? A little over 27 over 32?
9. Oh, I put the pi in the wrong place.
Oh.
Where's the pi supposed
It
to
should
be?
be in the denominator.
That's where I had it, and then I looked up and had it wrong.
See, I never put it in the numerator, I was just looking up there.
I don't know why I put it in the numerator.
Well, then, yeah, that'd be closer to 0.09 probably.
Because the pi goes in the numerator, evidently. Ready for another one?
Can we be done?
We can be done if you want to be done,
I
but
don't know, what's the next one look like?
an airplane?
With the triangle, do we have to do something with the triangle first?
Probably.
Uh,
Oh no.
Our assignment's kind of long for them all being story problems, I feel like, if they're all gonna be story problems.
We have 2 days.
We need 12.
Yeah.
They come around. So if it's due tomorrow night, otherwise there's also the weekend.
Mm-hmm.
I'm gonna almost this.
Homework.
Okay, an airplane is flying on a flight path that will take you directly over a radar tracking station. If S is decreasing at a rate of 400 miles per hour, when S equals 10, what is the speed of the plane?
Like 3 miles an hour, maybe?
Yeah, maybe. I don't know. Can they even stay? They can even stay in. Okay,
Yes,
so
you could not stay in the air.
could not even stay in the air, Kale. Okay, so the equation is
Natalie, how much did you dead with?
What do you think?
given and you're fine.
Couldn't move 335 off the ground. Austin got it halfway.
So we have what is the speed of the plane?
I got 325 and he couldn't.
Well, the speed of the plane would be like this x, wouldn't it?
Sure.
Well, I mean, if you think about it, because speed is going to be your direct. Yeah?
What are you talking about?
This right here basically shows your speed of your plane.
Yeah.
So that's dx dt.
Yeah.
Well, the picture has an x on it.
Yes, it has an X, sorry. I thought it was the Greek letter kappa.
Yep, maybe. When s is 10?
I hate in math how I write T's now. Like I started doing that like while I was writing something that wasn't in math.
You.
And so s has to be in miles, doesn't it? Because this is a distance.
Yeah.
Okay, so
Actually, I want to scale everything down to feet.
no. So it says if s is decreasing at a rate, so that'd be ds. DT.
Kilometers.
And if it's decreasing, it's not positive, it's
Negative.
negative. Miles per hour. Oh,
What is F?
the x is like your speed.
No, the S.
Just a distance from here to here.
Oh. I was not looking at the picture.
Yeah, you need to look at the picture. Without the picture, this problem does not work.
No.
Okay, so what equation can we use with this shape?
Triangle.
A triangle. How about Pythagorean theorem, right? So we're going to have x squared plus 6 squared equals s squared.
Sure.
Because S would be.
Because s is the hypotenuse, yes?
No, C is.
S equals C. Yes.
Now what?
Now we just find the derivative.
So find the derivative with respect to t. What's t? Time.
T, the letter after R.
I about just said 36.
What's wrong with that?
Because we're taking the derivative.
Ooh, the X primes were broken out for a second.
Wait. So if it's a constant with an exponent.
It doesn't matter, it's still 0.
Okay.
What? Oh, with an exponent. I thought you said for an exponent. I'm like, Natalie.
Stop.
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 Why are you like? Why is it? Oh, because are you dividing that 2x over?
I'm going to.
Well, why is it over there then?
Well, it had to because of the derivative of x squared.
Okay.
Where's X equal?
We don't know. I think we gotta do some math, don't you?
Oh, no.
I think we do.
Oh, so but we know that equals 10, so
So if this was 10, yes.
yeah, so X equals.
So x would equal the square root of 100 minus 36, which would be 64, which is 8. Actually, it's plus or minus 8. But can it be minus?
No.
No, it doesn't.
It can't.
It doesn't.
Yeah, no. Okay.
Distance can't be needed.
So we have s is 10, x is 8, and ds dt is negative 400 miles per hour.
Negative 40.
So that would be negative 50, right?
What? Oh, yeah, I did that.
So negative 500 miles per hour.
How do you try negative 500 miles?
What?
The plane just does it.
Because it's slowing down. The rate of the plane has to be slowing down. It's really not going negative. It's decelerating.
Okay, and it's like losing.
And it's decreasing. It's just like it's decreasing 500 miles per hour.
It's decreased.
Right.
Mine is
It's
only going 3
not.
miles an hour.
It is not going negative. It is decreasing its speed by negative 500 miles per hour.
Gotta be more specific.
How fast do planes go? I thought it was only like 500 miles an hour.
I don't think so.